The Earth, our planet, is different from what we see today. It began its life as a dead planet in the earliest days of Earth's history. The ecosystem has always changed over time, and in order to survive, all living creatures have had to adapt to different environmental impacts. Some microorganisms, called extremophiles, can withstand extreme conditions. These organisms survive in environments that reach physical and geographical limits where no other forms of life can exist. According to the modern model of the solar system, the oldest rock samples found on Earth are more than 4 billion years old, 4.03 billion in Canada and 4.4 billion in western central Australia. Scientists today have concluded that Earth formed about 454 billion years ago as a result of gravitational accumulation of millions of large and small rocks and dust orbiting the Sun. Life on Earth first appeared about 4.28 billion years ago, shortly after the formation of the oceans around 441 billion years ago, and not long after the Earth itself formed 4.54 billion years ago. Life on Earth may have originated from RNA-based cells, although RNA cells may not have been the very first. The exact mechanism of how life formed remains unexplained, but some believe in the Miller-Urey experiment. The earliest known fossils are of bacteria. In July 2016, scientists reported identifying a set of 355 genes believed to originate from the last universal common ancestor, LUSA, of all life. Originally, Earth was a hot, dead planet. Heavy metals sank inward and melted, pushing lighter materials to the surface as the planet cooled. At this stage, Earth was a giant black sphere with glowing cracks from molten material inside. These cracks would continue to exist for billions of years, often playing a decisive role in the survival of life on the planet. Billion years ago, a Mars-sized planet named Theia, formed during the early solar system, collided with Earth. The collision was catastrophic but also essential for life to exist later. It caused Earth's material density to even out, like shaking a jar filled with different candies. It also created the Moon. Material from both planets was ejected into space, forming a ring orbiting Earth, similar to Saturn's rings today. Gravity once again acted as a creator, pulling the debris together to form the Moon. At that time, the Moon was very close to Earth, and Earth spun rapidly. Under the Moon's gravitational influence, Earth's rotation gradually slowed, while centrifugal force pushed the Moon further away, sparing Earth from tides dozens of times stronger than today's most violent tsunamis. Around 4.1 billion years ago, the oceans in an oxygen-free atmosphere began forming. Between 4.1 and 3.8 billion years ago, Earth was filled with oceans as the cooling planet allowed liquid water to exist. Small asteroids and meteorites continuously bombarded Earth. These remnants of the early solar system carried water-bearing crystals and the simplest organic compounds into the oceans, where life would later arise. A billion years ago, Earth entered the Archean Eon. From the first organic compounds delivered by meteorites, amino acids formed in the oceans. The earliest simple cells appeared. Unlike us today, they were built on ribonucleic acid, RNA, rather than DNA, which makes up plants and animals today. Fossils of the oldest known life forms, around 3.5 billion years old, have been found. Initially, these were single-celled organisms that gradually clustered into thicker layers, forming microbial mats, the first living communities. Photosynthesis began supplying oxygen to our planet. The first simple glucose compounds also formed. Billion years ago, the oceans were filled with oxygen. Iron in the oceans oxidized and sank, creating banded iron formations. Today we use these 3 billion-year-old ores in modern construction. 5 billion years ago, the Proterozoic Eon began, marking the first major development of primitive life. The earliest multicellular plants appeared around 1.2 billion years ago, built from DNA rather than RNA. However, life's progress was soon interrupted. Around 850 million years ago, Earth entered the longest and harshest global ice age in history. Excess oxygen in the atmosphere blocked sunlight absorption, cooling the planet. More ice reflected more sunlight, turning Earth into a giant frozen mirror. For over 200 million years, Earth was an ice-covered globe with no signs of life. Around 630 million years ago, molten magma inside Earth reawakened, saving life. Volcanoes erupted after hundreds of millions of years of dormancy, breaking through some ice sheets, releasing lava and, most importantly, carbon dioxide. At that time, CO2 was life's savior, as it absorbed sunlight's heat. Combined with volcanic activity, The warming atmosphere gradually melted the ice, giving surviving life forms in the oceans a chance to evolve again. By 580 million years ago, multicellular plants had become widespread, and the first soft-bodied animals appeared. Fossils of such animals from this time have been discovered. A million years ago, oxygen continued to fill the atmosphere. At higher levels, oxygen formed a new protective layer, ozone. The ozone layer shielded Earth from harmful ultraviolet radiation, making it possible for life to spread onto land. The first continents appeared around 530 million years ago. Earth entered the Paleozoic era around 530 million years ago. This period witnessed the Cambrian explosion, a 30 million year burst of biodiversity. In the oceans, complex animals emerged, the most iconic being trilobites. Around 505 million years ago, the next stage of evolution began. During the Ordovician period, oceans covered the northern hemisphere while life thrived on the southern supercontinent Gondwana. Mollusks flourished and fish emerged, dominating the oceans until the Silurian period. A million years ago, during the Devonian period, a type of fish ventured onto land, using its fins to crawl. After millions of years of evolution, these became the first amphibians. Later, reptiles evolved. Meanwhile, insects resembling today's dragonflies and arthropods appeared, but much larger, thanks to high oxygen levels. Plants also grew to colossal sizes, reaching dozens of meters tall. From 360 million to 286 million years ago, the Carboniferous period, also called the Coal Age. This was a time when large numbers of plants died and accumulated underground, forming the coal deposits we use today. During this period, animals began laying eggs on land. Reptiles evolved to lay eggs containing water to nourish their young. The first ancestors of later reptiles were Hylonomus and Mesosaurus. While many plants died to form coal, another group emerged. No less resilient, tall clusters reaching 30 meters, including horsetails and ferns over 15 meters high, which covered the supercontinent Gondwana. From 286 to 248 million years ago, the Permian period, the final period of the Paleozoic era. This was a critical time for animal evolution. Some reptiles evolved into the earliest stages of mammals. For example, therapsids evolved from Dimetrodon, with teeth resembling modern mammals. They were fierce predators of the time. However, mammal evolution was not easy. Many animals, mainly reptiles, became victims of the greatest mass extinction in Earth's history, the Permian-Triassic extinction. The exact cause is still debated, but most scientists believe the extinction resulted from the merging of the continents Laurasia and Gondwana into the supercontinent Pangaea. Collisions disrupted the terrain, causing earthquakes and continental-scale volcanism, which destroyed countless species. Marine life suffered the most, with up to 95% of species permanently wiped out. After this mass extinction, the Permian ended, and the Mesozoic era began around 248 million years ago. This was the start of a new era, where some species adapted better than others and rose to dominance. The first stage of the Mesozoic marked the rise of dinosaurs, the most successful reptilian lineage in Earth's history. Early mammal ancestors like cynodonts persisted, paving the way for future mammalian diversification. However, mammals and fish were overshadowed by dinosaurs, which occupied every ecological niche, from small to enormous sizes. In the oceans, plesiosaurs and ichthyosaurs ruled, while on land, dinosaurs flourished in three main groups: theropods, predatory dinosaurs like Tyrannosaurus; sauropods, long-necked dinosaurs like Apatosaurus; ornithischians, including horned dinosaurs like Triceratops and armored dinosaurs like Stegosaurus. 3 million years ago, the Jurassic period began, a middle stage of the Mesozoic. Rift zones and volcanic activity caused the extinction of many marine and plant species, forming deposits that would become modern oil reserves, a key event in Earth's geological history. Meanwhile, dinosaurs continued to dominate land, air, and sea. Marine reptiles like plesiosaurs ruled the oceans, and flying reptiles like pterosaurs ruled the skies. Although they were not ancestors of birds, birds began evolving in the Jurassic from terrestrial carnivorous dinosaurs that developed feathers, a transitional form between reptiles and birds. Early mammals remained small, mouse-sized, and lived in hiding to escape predation. As million years ago, the Cretaceous period, Kai Fan Trang. This was the final stage of the dinosaur era and the Mesozoic, Flowering plants emerged, pollinated by insects, replacing older plant groups like ferns. Dinosaurs began to decline as vegetation changed, but remained dominant until 65 million years ago. Most scientists support the hypothesis of an asteroid impact, causing the mass extinction at the end of the Cretaceous. Evidence comes from iridium deposits in the Gulf of Mexico. A 10-kilometer-wide asteroid struck, triggering massive tsunamis, earthquakes, volcanic activity, and drastic climate changes. Dust and debris blocked sunlight, killing plants, depleting food sources, and causing abrupt temperature shifts, factors that led to the extinction of most large dinosaurs. Some smaller reptiles, birds and mammal ancestors survived because they required less food and could hide more easily. These mammal ancestors would then enter the Cenozoic era, the age of mammals. After the extinction of dinosaurs, birds remained sparse, and mammals adapted to hiding in burrows. By about 60 million years ago, mammals emerged, diversified into predators and prey, and became dominant. Around 55 million years ago, early primates appeared in tropical and subtropical regions, with flexible limbs, 5 fingers on hands, including opposable thumbs, and mobile necks. Early ancestors of humans, Eocene epoch, 55 to 33.7 million years ago. Tropical forests expanded. Ice remained at the poles. Many modern-like animals appeared, including hoofed mammals such as artiodactyls, ancestors of deer, and perissodactyls, ancestors of horses and rhinos. Early horses were small, dog-sized. Aquatic adapted predators evolved into whales. The direct ancestors of humans appeared about 3.7 million years ago. Australopithecus walked upright, adapted to savanna environments, evolving into Homo habilis, Homo erectus, and later Homo sapiens, with brains about 74% the size of modern humans. Modern humans appeared between 1.8 million and 100,000 years ago, developing intelligent social structures, and eventually spreading from Africa into Europe and Asia. Humans survived the last ice age, 12,000 years ago, and began organizing societies. Unlike dinosaurs, which dominated Earth for over 170 million years, humans have controlled the planet in a short time, advancing rapidly in population, society, and technology. The word dinosaur comes from the Greek dinos, terrible, plus sauros, lizard, first used in 1841 by Richard Owen. Early fossil depictions of dinosaurs differed greatly from what we know today. Megalodons were among the first dinosaur fossils ever discovered. Look at the initial sketches of them. Decades later, as researchers gathered more information, these drawings were revised to appear more realistic. Here is the modern depiction of Megalosaurus. To date, about 10,000 dinosaur fossils have been excavated worldwide by paleontologists, and over 900 species have been identified. Interestingly, from 2003 to 2022, an average of 45 new dinosaur species were discovered each year, and paleontologists' work is far from finished. Isn't it exciting to imagine discovering more dinosaur fossils? For example, in 2021, a bizarre dinosaur species was discovered in Chile with a blade-like tail and a beak instead of a mouth, named Securer. Now that we know a lot about dinosaurs, let's start the story from the very beginning, millions of years ago. Scientists estimate that the first dinosaurs appeared around 240 million years ago, based on the oldest dinosaur fossil discovered so far, 231.4 million years old in Africa. At that time, Earth was very different. Today's continents, Asia, Africa, Australia, Europe, were all connected into a single supercontinent called Pangaea. Scientists believe Pangaea looks something like this. Imagine the map. The climate was arid with only small amounts of rainfall. This period is called the Triassic, the era when dinosaurs first appeared. Early Triassic dinosaurs were quite small, usually around 2 meters long. For example, Ornithosuchus existed then and is considered an ancestor of later dinosaurs. The dominant animals of the era were giant reptiles, some of which are believed to be ancestors of modern turtles. Over time, Earth began to change. 201 million years ago, the Triassic period ended. The climate shifted, and Pangaea began breaking apart. While this shift may sound sudden, it occurred gradually over millions of years. Cracks appeared. Massive volcanic eruptions occurred along the fissures, releasing large amounts of carbon dioxide and sulfur dioxide into the atmosphere. This caused extreme global warming. Sulfur oxides and aerosols blocked sunlight, causing a temporary global cooling. Oceans became acidic as carbon dioxide and sulfur dioxide dissolved in water. The rapid climate change made survival difficult for most animals, particularly cold-blooded reptiles. Some warm-blooded dinosaurs, however, tolerated the temperature shifts better. Volcanic eruptions and climate changes continued for about 600,000 years, causing nearly all other species to go extinct. The only animals left on Earth were dinosaurs, crocodiles, turtles, and early mammals. This is known as the Triassic-Jurassic extinction event, marking the end of the Triassic and the start of the Jurassic period. If the name sounds familiar, it inspired the title of the movie Jurassic Park. The Jurassic period lasted from 201.3 to 145 million years ago, during which dinosaurs became the dominant animals. Some grew enormous, such as Titanosaurus around 160 million years ago, weighing 15,000 kilos and reaching 15 meters in length. Other iconic Jurassic dinosaurs included Brontosaurus, Brachiosaurus, and Diplodocus. Some dinosaurs evolved to fly during the Jurassic. One of the first feathered dinosaurs was Archaeopteryx. During this time, Pangaea had split into two smaller supercontinents, Laurasia and Gondwana. Although Jurassic Park popularized the Jurassic, the Mesozoic period where dinosaurs truly flourished was the Cretaceous period, following the Jurassic. At this time, dinosaurs saw a boom in diversity. Some evolved into the famous Tyrannosaurus rex, which reached the peak of dominance near the end of the Cretaceous, around 65 to 68 million years ago. The Cretaceous was the longest dinosaur period, from 145 to 65 million years ago. Laurasia and Gondwana began breaking apart, forming continental structures similar to today. Flowering plants appeared, global temperatures were warmer, and sea levels were higher. Almost every type of dinosaur you can imagine existed. Carnivores, armored dinosaurs, giant herbivores, Titanosaurus, Argentinosaurus, up to 77 tons, and T-Rex, up to 40 feet long, the apex predator of the time. An interesting fact, grass only began evolving 70 million years ago, so there were no grasslands during the story we're telling. Dinosaurs primarily ate other types of vegetation. Million years ago, some dinosaurs like onyx, ostrich-like runners, could reach 80 km/h. The largest flying dinosaur was Quetzalcoatlus, with a wingspan of 10-11 meters. The Jurassic and Cretaceous periods were the height of dinosaur prosperity, with favorable climates and abundant new species. Then, 66 million years ago, a catastrophic event occurred. A 10-15 kilometer wide asteroid struck Earth at 30 km/s, hitting the Yucatan Peninsula in Mexico. The impact created a 180 kilometer wide crater, releasing energy equivalent to 100 teratons of TNT, about 1 billion times more powerful than the Hiroshima bomb. The immediate effects were devastating. Fires, shockwaves, tsunamis, possibly 2 kilometer high, volcanic eruptions, acid rain, and earthquakes. Short-term impacts alone were deadly, but long-term effects were worse. Dust blocked sunlight for a year, causing a nuclear winter, killing plants and herbivores followed by predators. Only small omnivores, early mammals, lizards, turtles, and some birds survived by eating detritus, dead dinosaurs, and fungi. The asteroid also released carbon and sulfur from carbonate rocks, causing severe global warming after the dust settled. By the end of the Cretaceous, all large dinosaurs and over 75% of all species on Earth were extinct. The Cretaceous ended, marking the beginning of the Paleogene period. The asteroid, ironically, created an opportunity for the surviving mammals. With dinosaurs gone, mammals could evolve to fill ecological niches, eventually giving rise to horses, whales, bats, and primates, paving the way for humans. Some smaller snakes and lizards began to appear during this period. The only group of dinosaurs that survived were the flying dinosaurs, which gradually evolved into the birds we know today. Yes, that's right. The birds flying around you are descendants of flying dinosaurs. Most studies confirm that birds belong to the dinosaur family. Specifically, chickens and ostriches share the closest ancestry with dinosaurs. This is why people can say that the closest living relative of T-Rex, a fearsome dinosaur, is actually a chicken. You might wonder, how did we figure out where the asteroid landed? And how did we know it happened 66 million years ago? This was proven using a rare mineral called iridium. According to geologists, iridium is extremely rare on Earth, but scientists discovered unusually high concentrations of it in certain locations. Why is that? Asteroids and comets have high iridium content. Using radiometric dating on these iridium layers, scientists determined that the asteroid impact occurred 66 million years ago. You may also wonder, can we still see the crater from this asteroid? Yes, but not exactly as you might imagine. The event happened so long ago, and the continents have shifted since then. The crater lies mostly hidden in the Yucatan Peninsula, with part submerged underwater and part on land. Surveys and explorations have confirmed this location. Some sinkholes in Mexico near the impact site are now popular tourist spots. These sinkholes formed a vast underground cave system. After learning about the asteroid attack, you might think, what if such an asteroid hit Earth today? Humans could face extinction. Large asteroids are a real threat. Near-Earth asteroids are constantly monitored by NASA and other space agencies to calculate their trajectories and assess collision risks. As of April 2022, over 28,000 near-Earth asteroids have been identified. With more than 800 larger than 1 kilometer in diameter, many could potentially hit Earth, but there's no immediate danger because advanced scientific calculations allow us to predict asteroid paths accurately. We can even estimate the likelihood of an actual impact, and if necessary, take action to deflect it. This is the idea behind NASA's DART mission, launched in 2021. It was a test to redirect an asteroid. In September 2022, a spacecraft successfully collided with an asteroid, not on a collision course with Earth, altering its trajectory. If we can do it for that asteroid, the technique could be applied to any potentially dangerous asteroid in the future. However, asteroids aren't the only danger. Humans themselves are the current threat to life on Earth. The asteroid that killed the dinosaurs was Earth's fifth mass extinction. Scientists now believe that the sixth mass extinction is already underway, not caused by volcanoes or asteroids, but by humans. This is called the Anthropocene extinction. In the past 100–250 years, we have witnessed unprecedented biodiversity loss. Animals and plants are rapidly going extinct due to human activities. Biologists agree that this is a mass extinction event. Deforestation, ocean pollution, and atmospheric changes have accelerated extinction rates 100,000 times higher than normal. Thousands of mammals, birds, reptiles, and amphibians are endangered or already extinct. To counter this, the UN Convention on Biological Diversity held a meeting in Japan in 2010. 20 biodiversity goals were set for 2020. Unfortunately, only a few were partially achieved. In January 2020, a new plan called the Biodiversity Framework was established, aiming to protect 30% of land and oceans and reduce pollution by at least 50% by 2030. Scientists suggest that extinctions should be limited to 20 per year or less. It remains to be seen how many targets will be met. But one thing is clear, we must act, because if species disappear at rates similar to previous mass extinctions, humans may not survive either. Interestingly, humans have only existed for about 300,000 years in Africa. Compared to dinosaurs, which dominated Earth for 174 million years, humans are incredibly new. 300,000 years is 600 times shorter than the reign of dinosaurs. What do you think about this? Will humans ever surpass the record set by dinosaurs? Or might we go extinct within a million years? Share your thoughts in the comments, and don't forget to subscribe for the latest videos.